Hi, my name is Alberto Garcia. Today I'm presenting for the radiomics group at Moffitt Cancer Research Institute, and today's topic is going to be catching up with the de-identification standards within the UO1 grant and the RO1. So firstly, we're going to go over a quick overview of what we're going to cover today. First off, I'll be answering the question of why we are looking at changing DICOM strippers, or what needs to be addressed for our next project. What we have been doing in the past. We've been using Conquest, as you all know. And I'll go over what it does exactly and what it can't do, which is why we're changing. A lot of the reason we're addressing this issue is because of the wastes, and so we'll be going over a few of those, as well as the history of alternatives. We have visited this issue in the past, but we haven't been able to find a viable alternative that fulfills all of our needs. So we've just reverted to Conquest for the past few analysis. We have a best option now that seems to fulfill all of our requirements. So I'll be outlining that, and as well as the benefits and risks of moving our pipeline over to that. Final recommendations will show you the workflow, or the anticipated workflow that we expect to be seeing, and then of course we'll be thinking. So our current workflow uses Conquest database. It's basically a PAX server. What it does is runs a little local server on your workstation, and it's set up to receive any pushed images. So any images that we bring from the clinical side, GE or Imagion, we start pushing those images that we require for research, and they will show up in this local database. As they're on that server, we can go two directions. One, we can send them to our local shared drive. We can just make a copy there, or we can create a de-identified version by right-clicking within the Browse Database tab. Then we click Change Patient ID, and it does a very one-size-fit-all, not very customizable stripping of all headers that contain PHI. The problem with this is there's quite a few custom headers, such as patient address and patient provider, that do provide some reference to who this person is. So it's kind of borderline for PHI. Another issue that we have with this is this is a one at a time process. So each patient, each study has to be de-identified separately. So while this has worked in the past, we've had to use quite a bit of man hours and even hire another FTE to handle processes like these, all these manual processes that we were unable to automate. So to share a little more on these wastes, this is a manual effort. We have to do single transmissions. These images are arriving one by one, and then they have to be changed manually. So there is a human input for each and every case. We have to type in the new PID number, and we can't give them pseudonyms. So we do have limited control, and any output given us by Conquest is going to be in the raw format. They're just DCMs in a stack. There's no formatting or folder hierarchy for the output. The server is very separate from all of the rest of our workflow, and it's just a huge detour in what we're doing. So probably our team has been looking at alternatives for this process for 2 years. We have tried writing some of our own scripts that have been successful to varying degrees within MATLAB. There are randomizers that change the PIDs, and they also change the patient names, but doing something as complex as reading the DICOM header and deciding where each consecutive series that hits the program, where it should be associated with, that's going to take quite a bit more research and coding time. DCMTK does offer some libraries for DICOM reading and handling, and it has made these MATLAB scripts possible, but they are still very limited, and they still require quite a bit of know-how just to run. One of the other alternatives that are third-party pre-built is Osirix Lite. However, the customization available is very, very limited unless we do the paid package, which still won't offer everything we need. So at the beginning of our U01 grant, our associates at Maestro Clinic in the Netherlands showed us what they were using, which was the clinical trials processor, which was brought to us by the RSNA. And basically what that workflow looks like is it's coming from the modality packs. It's another local server, just like Conquest, that's listening for images and incoming DICOM files. Once it receives that, however, the process is quite different. It has its own lookup table, which we can configure within a text editor. It compares the PIDs and identifiers of the incoming images and references a table that we've provided. It will batch process these images that come in, and using the spreadsheet will strip any images. And the nice part about that is we can customize the de-identifier itself. So any headers, or each and every one of the headers, we can say how we want it manipulated. If we want a dummy value that stays consistent across all of the data set, such as date of birth, if we want them all to be the same, and gender, we want those to be neutral, we can have a value rather than just stripping and leaving blank data, because a lot of these pack systems, they have trouble with null values. So real quickly, since we're running out of time, we're going to go over the benefits and risks of the new program. Batch processing is the largest benefit. We are expected to do somewhere near 4,000 cases, which is quite a large increase since NLST dataset, which was about 700 patients. This bandwidth increase is going to require retooling, and there's really no other way that we can hire enough men to to process all these individually. The nice part about this is it does remove almost all human input. We provide the Excel spreadsheet and then just start sending, so everything else is taken out of the human hand. There are minimal risks, in my opinion. The output is still raw. However, we have written MATLAB scripts in the past which will just read the header and sort everything into its own folder hierarchy based on what it finds. So that shouldn't be a large problem since we've already solved it. So our final recommendation is an improved workflow that looks something like this. So from the clinics, we're sharing straight to CTP, or we can send it locally and still keep that that share file or share folder with the original identified copy. From there, we can send it, use Mobius send tool to do a PAX push that will receive by the clinical trials processor. And from there, the best part is that the backend, the output, is automatically routed to our archive, the National Imaging Archive. So as soon as it's paired up the images, it will de-identify, strip the header exactly as we've tailored it, and it goes to MBIA, which at that point our QC guy will have to review the headers and in a HIPAA-approved quality control method before outside institutions can view these images. So everything will be quite cleaned up instead of all over. And very quickly, I'd like to just go over our works cited here. MIRC, CTP, their documentation can all be found at this location, and yeah, without this, none of this would be possible. DICOM Cleaner was another one of the resources that we tried in the past, and the documentation is there as well. Thank you so much.